Hello everybody, welcome to Embetronics. In our previous video, we have seen how to create major and minor numbers. We have created it in two ways. One is the static method and another one is the dynamic method. In our upcoming video tutorials, we will be creating the major and minor number using the dynamic method. Okay, now we will see what is the device file and how to create it. Let's get started. What is the device file? Let's assume that we have the hardware and this is the device that wants to communicate to the hardware. The device driver will be there at the bottom level. This is the kernel space and this one is user space. When the application wants to talk to the device driver, it has to go through the device file. The application will open the device file and it will write the data to the device file. Then the device file writes the data to the device driver and the device driver writes it to the hardware. When the application wants to read the data, it will do it by going through the device file, device driver and hardware. In our previous tutorial, we have assigned the major and minor numbers to this device driver, but we have not discussed that how to create the device file. Basically, most of the device drivers may create a device file. For example, run this command ls-l dev. See here, these are the device files that are available in the Ubuntu machine. See, the STA driver's major number is 8 and the minor number is 0. STA1 has the same major number but the minor number is 1. STS2's major number is 8 and the minor number is 2. It goes like that. When you want to get the data from the hardware, just read this device file. When you want to write the data to the hardware, just write the data to this device file. So, whenever you create the device file, it will create the file under the dev directory. I hope you understood the concept. Let's see how to create the device files. There are two ways that we can create the device files: automatic creation and manual creation. First, we will see how to create it manually. We can create the device file manually using the mknode command. The first argument is -m. The next argument is the permission of the device file. This is the name of the device file, so this name will be available under the dev directory. We have to tell the kernel that this device file belongs to the character device or block device. Then finally, we have to give the major number and the minor number which we have allocated. See the example here. Sudo mknode -m 666, that means I am giving read-write permissions to the user, group and others. I want to create the device file etx driver under the dev directory. C is the device type, character device. If you are creating the device for the block devices, then you can use the B instead of C. And 246 is the major number and 0 is the minor number. You can use this mknode command before loading the driver or after loading the driver. Now we will see the code for the manual creation. I have not made any changes to the source code. I have just taken the source code from the last tutorial, dynamic major and minor numbers. In the init function, I am allocating the major number and unregistering the major and minor numbers in the exit function. This is the make file that I am going to use. Let's see how to create the device file manually. Let me build the code in Ubuntu and Raspberry Pi. Then load the module using the ins mode. Check the D message. Okay, our driver is loaded. Let's check the device file. See, our device file is not created yet. Run the same command in the Raspberry Pi as well. Here also, the device file is not created. Now, we have to find the major and minor number. Use cat proc devices to find out that 237 is assigned to our driver. Now we can create the device file using the mknode. Sudo mknode -m 666 dev etx device c 237 because 237 is the major number and the minor number is 0. Now let's check the device file. See, that device file is created. Let's do the same thing in Raspberry Pi. In the Raspberry Pi, the major number is 235. Let's create the device file. We have created the device file. We can unload the driver using the RM mode. Even after you unload the driver, the device file will be there because we have created it manually, so it will not be deleted automatically and we have to remove it manually. Now we will run the same driver in BeagleBone. I have modified the make file for the BeagleBone. Cross-compile the driver. Now copy the driver.ko file to the target. In the serial terminal, load the driver using the ins mode. Get the major number. 241 is the major number. Now we will create the device file using the mknode. See, the device file has been created. Do you really prefer this way of creating the device file? Before I am asking this question, we will see the automatic creation. In the automatic method, we have to follow 3 things. First, include this header file. Second, create the structure class. And finally, create the device file with the class. Using this class create API, we can create the class. It will create the class in the sys class directory. The first argument is the owner and we will give this module. And the second argument is the class name. This function will return the class. You can delete the class using this class destroy function using this class pointer. Once after creating the class, now we can create the device file using this device create function. This is the class structure that we have created already. This is the parent of this device. We will give null to this argument. We can give our major and minor number using this dev argument. If you want to pass the data, then you can use this argument. Finally, we can provide our device file name. When we call this function, it will create the device file under the dev directory. If you want to delete that device file, we can use this device destroy function. Now we will see the code. I have included the header files. This dev is to store the major and minor number. This structure class pointer is used to store the address of the class structure. In the init function, we are just registering the major and minor number. After that, we are creating the class named as etx class. Then we are creating the device file using the device create function. It will create the device file named etx device under the dev directory. In the exit function, we are removing the device file class that we have created and unregistering the major and minor number. Now we will see the demo. First, we will run this code in Ubuntu and Raspberry Pi. Build the module. Load it. Check the D message. It has loaded successfully with the major number and minor number. Now we will check the device file. It has been created automatically in the Ubuntu and Raspberry Pi. Let's unload the module using the RM mode. If you check the device file, it will not be there as we have deleted it in the exit function. See, the Raspberry Pi also has the same output. I want to show you one more thing. I said the device file is one file where we can read and write data. Load the module. Now we are trying to read the device file using the cat command. See, we are getting the error no such a device or address. In the Raspberry Pi also we are getting the same error. We are getting this error because we have just created this device file and not assigned the file operation like read write to this device file. In our next video, we will see what is the file operations and how to link that to the device file. Unload the modules. Now we will run the same code in the BeagleBone. Cross-compile the device driver and copy it to the target. Now we will load the driver. Sorry, we have to unload the previous driver. Now we can load it. Check the D message. It has loaded successfully. The device file also has been created. Let's unload the module and check the device file. It won't be there. If you like this content, please like this video and subscribe to our YouTube channel. In our next video, we will see the file operations. Thank you.